Hey guys, hi. So in this video we are going to discuss one of the most important paradigm of sorting algorithm, and mainly the tools which we use in order to solve complicated problems. Okay, so custom comparator and lambda functions are two different tools which we use in order to solve complicated sorting algorithm. Before we move on to the implementation and the definition of each of them, let us look how we can sort the given array in C++, right? So in C++ we can use the STL's sort function, and we can give the start iterator and the end iterator of the given list. So this will be something like nums.begin in C++ if I'm taking vector as the input array, and this will be nums.end. Okay, now this is good enough. Why do we need any other operator on top of them? The problem is the default sort operator sorts on the basis of the value, and the default one is in ascending order. Now in order to do it in descending order, we can just sort the array and then take a reverse of this array, but that's also in the descending order. What if I give you some example wherein, let's suppose some numbers are given 7 7 8 8 8 9 10, and I ask you to sort these numbers on the basis of the frequency of the numbers. Now how we can do this, how we can sort on the basis of frequency of these numbers? It cannot be done via the default sort function, right? Obviously, because we are not sorting on the basis of some other attribute, we are just sorting on the basis of the value of the numbers which are given to us. So in these kind of cases, we often use custom comparator. What does custom comparator do? If we look at the default sort function, there is a hidden operator as the third parameter. When we do sort, this is my first iterator, this is my second iterator. The third one is the Boolean compare function, which none of us uses. What is this? This is generally the compare function, Boolean function, which will tell me how we can sort the given values. If this list is given to me, wherein first is the first iterator, the last iterator is given to me, sorry, this is last iterator, not the second iterator. And how we can custom compare the values which are given in the sorted array, or in order to reach the sorted array. So in these kind of cases, we use custom comparator. How do we use custom comparator? Generally, we define a custom function which we pass here, and the definition of this function something looks like this: bool compare. We give some arguments, and within the definition we return the logic. So this is the logic which we use in order to compare two different elements. So suppose if I was to solve the frequency wala problem, and I have a frequency array for all the numbers. If two numbers are given to me, integer a comma integer b, what I do, I will return the one which is having the higher frequency. So I will do frequency of b is less than frequency of a. That is what I can do here. So this will sort the numbers on the basis of the frequency of which has been provided in the given question. Now we often get confused a lot via this symbol on when to use the less than, the when to use the greater than. So I have a simple formula for this. The default order which we use is something like this. If int x comma int y is given in the question, in the custom comparator, let's suppose this is my compare function, the default one is x less than y. If we are doing this, then this will give me in ascending order. So to get it in descending order, we do something like this: x is greater than y, and this will give me the descending order. Okay, now how do custom comparator works? It's very complicated internally. It uses a wrapper of quicksort which they internally implement, and then they override the compare function which we have customly defined here. But in questions we can use it something like this, wherein if we want to assign sort order the elements in ascending order, we can give x less than y, and it will depend, like this could be any kind of data type. I am just taking the integer data type, and if want to sort in descending order, I will get x greater than y. So this is how we can sort different numbers according to a custom comparator. Now there's a problem, right? Because this function is going to be a global function. We always need to define it in global function. Why do we need to define it in global names like space? Because the library, the sort library is a global library, right? In order to override the existing function, in order to override the existing compare function, we need to define it globally. And this creates a lot of problem because sometimes the scope of the main function will be overridden. So we have to define a frequency array again in the global space and then copy all the elements and the frequency in the main array. So in order to avoid this, we use something known as lambda functions. Okay, now lambda functions, if we discuss, lambda functions are generally a proxy for custom comparator. How do we use them? We can use a lambda function within the main function only. So suppose if I want to sort an array, let's suppose this is the start iterator, this is the end iterator, and instead of giving the compare function, I can define the lambda function here only. So lambda function mainly consists of three parts. Okay, the first part is basically scope. The second part is known as variables or arguments, and the third part is known as logic or return type. So how do we define it? First I define the scope here. Okay, then I define the arguments and then I will define my logic. So this is my logic for return type. This is going to be my scope and this is going to be my variables or arguments. Now you might be getting confused like what is what. So let us try to understand lambda function in custom comparator through a problem statement. Okay, so if we read this problem statement, we have to sort the string s which is given to me on the basis of the frequency of characters. Okay, so till now what we have seen in the sort function is, sort function will basically take two different parameters. The first one is the start iterator and the second one is the end iterator, and it will sort in the ascending order. So one thing to understand here is the default operator which we use for ascending order, which the C++ library uses, is this. Okay, so to sort in ascending order, we use the less than operator and it will sort the string in ascending order all the time. So now this is the drawback of the sort function, wherein we cannot sort it using some other parameter, right? So what we can do is, there's a third parameter which is hidden in most of the sort function, which is the compare function. Okay, now this compare function already has a built-in definition in C++ library and it uses by default the less than operator. So less than basically sort in ascending order. So what if we want to basically sort with respect to decreasing order, right? So we can use the greater than operator if we want to sort in order of decreasing. Okay, and if we want to use some other parameter, some other logic in order to sort the string, we have to define the logic. So with this example, let us see how we can use the custom sort function in order to sort this array using some custom logic. Okay, so the first thing which we plan to do is, let us try to basically define a frequency vector, right? So we need the frequency vector in order to sort the array elements, right? So we will create a frequency vector of 256 characters, and let's suppose this frequency vector has 256 characters. I will initialize all of them with 0. Now we need to increase the frequency and create the frequency vector. So for this I will do character C going through all the string characters of S, and frequency of C is ++. So this will actually create a frequency vector for me. Now it is simple, we just need to define the sort function here, sorry, nums. I will give the start iterator here and then I will give the end iterator. So once I give this start and end iterator, I have to give the third parameter, which is the compare function. Now the default compare function definition is present in the namespace of STL, but we don't want to use it, we want to override the definition, right? So how do we override the definition? We need to define this compare function in the global namespace. So what I will do, I will define this here. So I will define a function here, bool compare, and this is the standard logic for defining all such functions. We will keep two different parameter, which is the atomic unit of this string. What is the atomic unit? Basically it's the character. So I will define two characters, character A and character B, and then I have to write down some logic for sorting. Now in this logic I need to use this frequency vector, but since the scope of frequency vector is defined inside this block, we need to copy it as in a global vector. So I will just create a global vector here, global int g underscore frequency. This is my global frequency vector, again same definition, comma 0, and yeah, so we can define it like this, and here I can do g underscore frequency is equal to frequency. We can also like define it all the time, we don't need to do this declaration, but yeah, just for the sake of understanding I have done it. So once we have this frequency vector, let us see what is the logic. So the logic for sorting would be return the one which is having greater frequency, that will be given the preference. So what I will do, g underscore frequency of A greater than g underscore frequency of B. That is what I want to return here. Okay, and we will just return this string. So this will actually sort the string with respect to decreasing order of frequency. So let us see whether this code is working or not. Okay, it is working great. Now there is one edge case which we are not targeting, which is what if the two different characters, like what if the frequency of two different characters are equal. So they are given in the problem statement, like if the frequency of two different characters are equal, then we have to follow the lexicographic order. So this condition also we need to handle here. So what I will do, I will write down if frequency of g underscore frequency of A is equal to g underscore frequency of B, in this case return me the lexicographic order. So I will do A less than B. Now notice here I am using less than operator because I want to sort in increasing order, whereas the frequency I want, with respect to frequency I want to sort in decreasing order. That is why I am using greater than operator. So just make sure you understand this greater than and less than operator. I'll just write it down. So less than operator is used for ascending order, and greater than operator is used for descending order. Okay, just remember this thing because it will be used a lot. Now let's try to submit this code with this logic. Let's try to run this once. We will try to just submit this code, and it is running great. Okay, now this is about custom comparator. What about the other thing which we have discussed, which was lambda function? Okay, so if you see, there is a boundation here wherein we have to define it globally, right? So we have to copy paste all the characters again and again in order to make this work, and we don't want to do this, right? Obviously we want to do this because then we have to copy paste the scope, like we basically are copying g underscore frequency in order to use it here. So there is an extra memory which is getting utilized here. So for similar purposes we have something known as lambda function. So instead of this compare, I will use now lambda function. I will use something known as lambda function. So lambda function has three different attributes. The first one is known as my parameters. Second is the scope, and third one is the logic. Now let us see how we can implement each one of them. Okay, so for defining it lambda function, let me just first of all comment out this code. So for lambda function I have to maintain the same frequency vector, but here I will first of all define the scope, and then the attributes, parameters, sorry, and then there's a logic. So this is actually the scope. This is known as scope. I'll just write it down here. This is basically my scope. What is this scope? This scope is basically what I want to use inside the logic. So this is external variables in logic. Okay, what is the other thing, which is this actually is the parameters which I want to pass. Okay, so if we want to define the logic here, parameter would be similar only. This will be atomic unit of the array which I want to sort, and the logic is going to be similar to this. So I will just use the same logic. Let me just copy paste the same logic here. Only thing is it will not be g underscore frequency, no, it will be frequency only. Okay, now what is the third thing which I want to plan? This thing. So this is actually the scope of variables which I am using here. So if you see within this block, what is the external variable which I am using? It is the frequency vector. So we can pass the frequency vector here, or we can just mention equal to. So what does equal to do? Equal to basically takes the global namespace. So equal to basically means I am taking up everything whatever is defined out of this scope. Okay, so that's how we can sort this using the lambda function. Now let us try to run this code. Okay, great, this is running. Let me just try to submit it now. Okay, so if you see, this is how we can implement it using lambda function, wherein this is the scope, these are the parameters, and this is my logic. Okay, similarly there are a lot of different questions which can be done with this. I personally prefer lambda functions over custom comparator, because in custom comparator sometimes we need to like use a lot of memory, because we need to then define a variable global and then copy paste the global variable scope within the main function. So we can use either of them, it's up to you. If you're compatible with custom comparator, you can use custom comparator. If you're comfortable with lambda function, you can use this lambda function. Okay, both are just the definition for the third hidden parameter, which is the custom compare function. Okay, so this is how we can define custom comparator or lambda function.